equations first. All right, we will take a look at why this happens. So we will take a look at this from a graphical approach. All right, so basically what we're going to have here, just to kind of visualize it, we're going to have an absolute value bar around some expression, and I'm just going to let that expression be u. That's going to be some function of x, maybe a 2x plus 3, maybe a 4x, all right, anything inside there involving our traditional x. And then for it to be an equation, we need an equal sign and then set equal to a constant, okay? Now, that's not to say that I can't have absolute value bars on both sides. It's not to say that I can't have absolute value bars on the left and maybe a 2x plus 5 on the right. All right, there's a variety of ways to set this up, but just generically, this is what it's going to look like. All right, now, because absolute value basically is the distance from 0, okay, how far is it? When I solve for x, I'm probably going to get 2 answers, okay? So algebraically, what we're going to do is we're going to take whatever is in this side, the absolute value bars, drop the absolute value bars, but keep what's on the inside, and then set it equal to c. And then it will be an or always on the equations. Then I'm going to take what's in the inside the absolute value bars, drop the bars, so it'll be just a u. And then we're going to go equal negative c, okay? So that part right there is going to be the opposite sign. Easy way to remember that. Okay, now actually, I think what I'm going to do is I think I'm going to take a graphical approach to this first, and then we're going to do one algebraically. Okay, so like, let's say from a graphical approach. And we're going to do it without our graphing calculator. You could do this with your graphing calculator, especially if you don't have these equations memorized as to what they look like. Okay, but let's say that we had an equation that looked like absolute value of a 2x minus 3 equals 11. I am going to reference our TI-84 graphing calculator. Okay, so the way you would solve this on that graphing calculator is you would take this portion and you would put it in y1, and we've done enough with the graphing calculator, you know what y1 is, it's where the first equation goes. All right, and then you would put this one in where y2 is, okay? And this approach is called the intersect method. All right, graphing it in this way and using a graphical approach to solve it. It's called the intersect method when using your graphing calculator. And then because it has the name of intersection method, wherever the two lines would cross, those are where your solutions are. All right, so where the two graphs cross would be the solutions. Okay, so now what I'm going to do is I'm going to sketch it. Rough sketch. I don't want to pull up a graphing calculator right now. Okay, so absolute value, if you remember from a long, long time ago, absolute value is a V shape, right? And basically what this means I'm going to shift to the right 3/2. All right, I know that just because I have it memorized, but this is shifted just a smudgy bit to the right, okay? A smudgy bit to the right, and then it's an upright V because there's no negative leading coefficient or anything. All right, so this right here makes a V. So if you were graphing that on your graphing calculator, there would be the V. All right, and then I'll go ahead and use a different color. All right, if I graph the 11, if the calculator were to graph 11, that's like y equals 11. So that's a horizontal line at 11. So right here where 11 is, the calculator would graph a horizontal line. Okay, now, if this method is called the intersection method, then wherever the V crosses the horizontal line are going to be my solutions. All right, so it crosses right there, it crosses right there, okay, which this turns out to be a -4, this turns out to be a 7. All right, so it's giving me 2 answers. All right, it's giving me 2 answers. It's given me x equals -4 or x equals 7. Okay, so from a visual standpoint, a graphical standpoint, these types of equations are going to have two answers, and this is why, because they're V's. They're either going to be upright V's or upside down V's, okay, but regardless, there's still going to be a V. All right, and if I set it equal to a constant, definitely, if it's constant, there's going to be a horizontal line. It's going to go through there. It's probably going to cross it twice, could cross it right at that vertex, okay, but it is probably 9 times out of 10 going to be right there and cross it twice. Okay, now that's a graphical approach. That's what you've got going on. Now we're going to take this exact same example and solve it algebraically, and I'll show you where these two come from an algebraic standpoint. All right, so if I had absolute value 2x minus 3 equals 11, okay, algebraic approach. Okay, going back to what I said just a minute ago. This is our setup. We're going to drop the absolute value bars, write exactly what we see, u equals c. Then we're going to take what's inside there, drop the absolute value bars again, but take the opposite sign. So that's how we're going to set it up. So I generally do this, two little things. That indicates I'm going to have two different equations. I'm going to take exactly what is here, and the only thing I'm going to do is drop those bars. So I'm going to drop the bars. I'm going to write 2x minus 3 equals 11. Okay, the only thing I do is drop my bars. All right, on an equal, it's always the word or. Okay, so it's always an or. All right, and then I'm going to write this again, drop the bars. Okay, but then this time, I want the opposite sign. So I'll have a -11. Now, what this has done is it's created two two-step equations, nice little equations that we can solve. All right, if I add 3 to both sides, we can do the math really quick here. 2x equals a 14, x equals 7. Okay, we add 3 over here. It's going to be a 2x equals, this side is different, -11 plus 3. That's going to give me a -8. X equals -4. Okay. Now, probably in high school, you stopped right there. You circled that. You wrote that as your answer right there. Okay. We're going to use a solution set. All right. Because we have two answers. Okay. So in our solution set, we'll have -4. We'll have 7. All right. Now, one thing I didn't do is I didn't check. All right. You must check your answers. All right. So check, definitely check them, plug them back in the original equation. All right. But since we had originally done this one from a graphical standpoint, I already know they both work. Okay. So on this one, I technically don't have to check. Okay. So what that does open up for you, you can check algebraically. You can also check on your graphing calculator. Okay. It gives you more options on different ways that you can check. Okay. All right. So conceptually, are we good? What we're doing here, straightforward, maybe. All right. I'll let this person in the Zoom meeting. Okay. All right. Now, there is one additional note that's got to be made. This problem right here, the absolute value bars on the left-hand side are isolated in the sense that there's no number being multiplied in front, and there's no number being added or subtracted right there in between the absolute value bars and equal sign. Okay, so that's an important thing. If it is, you have to isolate it first. Those absolute value bars have to be isolated. So we're going to make a little note. All right, we're going to say you must, and I'm going to use the word isolate because that just means I want the absolute value bars on the left-hand side of the equation by themselves with nothing else there. So you must isolate the absolute value bars before and the before is crucial, before you split the equation into two equivalent equations. Equivalent equations without bars, for a lack of a better way to say it. Okay, now let's do an example of what I mean by that. Okay, there's a possibility, and I'm going to do both multiplication and add and subtract in this one, just so you see both in one example. That way we only have to do one example maybe. Let's suppose we had a 5 and then an absolute value bar, 1 minus 4x. And then we had a minus 15 is equal to 0. Okay, I already set to 0. All right, now this isolate thing, what I'm talking about, if I have numbers that are being multiplied, that 5 is being multiplied by the absolute value bars. Okay, so it's not isolated. Here's the center of my equation. The equal sign is the center. And on the left-hand side, there's a minus 15. So things are being added and subtracted. Things are being multiplied. I have to get rid of all of those before I can break it up into 2. All right, so my first thing I'm going to do is add 15, because we would normally just add a plain 15 just to get rid of that 15. I'm still going to have 5, absolute value 1 minus 4x, 0 plus 15 is 15. Okay, now we still have the 5 being multiplied. So I've got to get rid of that 5. Okay, we get rid of the 5. It's 5 times the absolute value bars. So I'm going to divide by the 5 so that they cross out on the left. I'm going to divide by 5 on the right. Then I will actually be down to an absolute value of 1 minus 4x equals 15 divided by 5 is 3. So I have at this point isolated my absolute value bars. Once you are to this step, now it's when you break it up into 2 equivalent equations. Okay, so you write everything down exactly like you see it for the first one, except you drop those bars. So 1 minus 4x is equal to 3. It's always going to be an or. Okay, and then you write it again, drop the bars, but take the opposite sign. All right, you take the opposite sign right there of whatever's on that right-hand side. If there's more than one thing, you take the opposite of both. If there's absolute value bars, I still take the opposite. Doesn't matter. Whatever's on that right-hand side, you got to take the opposite of it. All right, now these are 2 simple little 2-step equations. So hopefully we can do this in our head really quick. Minus 4x is equal to, subtract 1 would be a 2. So x equals a negative 1/2. Okay. And negative 4x equals, let's see, subtract 1 there will be a negative 4. Don't let me screw up. X equals 1. Okay. If we're writing it with an or, which you guys won't be, but you probably did in high school, you would stop right there and leave your answer there. But we're going to use a solution set. So we'll write it as a negative 1/2 1. All right. Again, I need to check. All right, both of those answers, plug them back in and see what happens. All right, if I plug a 1 in, that would be a negative 3. Negative 3, absolute value is 3. 3 times 5 is 15. 15 minus 15 is 0. So the 1 clearly checks. Negative 1/2 here is going to make that a 2. 1 plus 2 is 3. Absolute value of 3 is 3. 3 times 5 is 15. So the negative 1/2 checks as well. All right, most of you are going to be able to do that in your head, just like I did. But if not, grab a graphing calculator. Okay. All right. You could put this in Y1. You could put 0 in Y2 and then see where they cross. Use the graphical method to check it. Okay. All right. So far, so good. Questions? All right. Now, what we've not addressed is the fact that absolute value, if I just take the absolute value of a number, it's always positive. Okay. If I just plain good old fashioned absolute values, we haven't talked about this. Okay. So if I just had absolute value of negative 4, all right, well, we always know that's 4, right? It's going to be a positive of whatever it is. If it's an absolute value of 6, what's my answer? Well, 6, right? It's always positive. absolute value gives me a positive answer when I'm just taking the absolute value of a single number. Okay, now with that being said, then we are going to run into a special case. All right, what if they try to give you an equation that looks like absolute value x plus 6 equals negative 12? This is actually where I would like you to think through this a little bit. Are the absolute value bars isolated? Yes. Nothing is being multiplied, nothing is being added or subtracted. So they are isolated. Okay, but stop and think about what this is saying. I'm trying to find x, right? So what number could I plug in here when I add 6 to it and take the absolute value of it that I will get a negative number? Well, absolute value is negative, never negative. Absolute value is negative, never negative. There is no number that I'm going to be able to plug in for x and then add 6 to it and take the absolute value and get a negative number. It can't happen. Okay, so in which case, then you can write no solution. All right, this is just one that you're going to need to remember. All right, other ways to write no solution, you could do a set of brackets and have an empty set. All right, you could also use the circle of a line through it. That's empty set as well. Okay, all right, now the thing is, you've got to, when that happens, you've just got to be awake and pay attention, because watch what I do real quick here. This is going to be wrong, so don't do this. All right, but if you are not paying attention, all right, let's say you don't realize that's a negative absolute value can't equal negative, and let's say you go through the whole process, negative 12, x plus 6 equals a positive 12. I change the sign. Can I subtract 6 over here and get x equals negative 18? And can I subtract 6 over here and get x equals 6? I mean, my algebra just worked. I just worked it out and got 2 answers. So just because the math works doesn't mean you're doing the problem right. The absolute value can't be negative. So this is the wrong approach. And if you're not paying attention and catch the fact that this is set equal to a negative number, then you're going to work it out like this. You're going to get 2 numbers. You're going to think you're right. Okay, so just something you got to pay attention on that one. Okay, all right, now we've got one more thing that we've got to do with absolute value equations. All right, so far I put a constant on that right hand side every time, but I don't have to put a constant on the right hand side. So what are you going to do when you encounter, say, absolute value 3x minus 1 equals absolute value x plus 5? Okay, this is, I guess you could say, another special case. I don't know that it necessarily is a specific special case, but it's just not a constant on that right-hand side. The overall principle of what we have been doing stays the same. Okay, so we've been dropping the absolute value bars. We've been keeping everything the same the first time I write the equation. The second time I write the equation, we take the opposite. So that same process, we're still going to go through and do. So I'm going to break it up into 2 equations. My first equation, I'm going to write exactly what I see without the bars. So I'm going to have a 3x minus a 1 equals an x plus 5. That gives us a nice little equation to solve. All right, it's always going to be an OR because they're equal signs and they're absolute values, so it's always going to be an OR. Now, this time, I write the exact thing. I drop the bars, except I have to take the opposite of this. Okay, so I'm going to actually probably put in an extra step here. So 3x minus 1 equals the opposite of this binomial. So negative x plus 5. This is taking the opposite of the binomial. I put this set of parentheses around it, meaning I'm taking the opposite of the entire thing. All right, basically that means to what? Then go through, change the signs, distribute that negative. Okay, so you could think of it as changing the sign of each individual piece. You can think of it as I'm going to take the opposite of the entire expression. Okay, so let's go ahead and finish this side over here since we're talking about this one. 3x minus 1. This becomes a minus x minus 5. I needed the opposite of both of them. Okay, here I'm going to add x to both sides. So that'll give me a 4x. I'm going to add 1 to both sides. So negative 4x equals negative 1, as long as I didn't make a mistake there. All right, this one over here, this one should go relatively easy as well. Subtract x from both sides. That'll give me a 2x. Add 1 to both sides. That's a 6. So then I get x equals 3. All right, again, if I were writing it in an Algebra 2 class, I would probably leave it like that with the word or in between, but we want that solution set. Probably before you write your solution set, you should probably plug them both back in and check. All right, I'm almost positive they both work. So negative 1, 3. All right, we'll just write check over here to remind you, you should always check. If one of them does not work, it's called an extraneous root and you can throw it out. Like if I would take that 3 and plug it in and it not make a true statement, I would have to throw it out. It would be an extraneous root. So then our answer would only be a negative 1. So far, I haven't done an example like that yet. All right, now that takes care of the equations. Okay, absolute value equations. That's pretty straightforward. The textbook does that approach, same approach as I just took. All right, because there's really only one way to do this. Okay, so now from this point on, we're going to do absolute value inequalities. I'm going to take one approach in here with the lecture. If you don't like the approach I take in here, you can download the online notes and use the textbook and take their approach, because really it does. I don't care which method you use. All right, just as long as you understand this. Okay, so absolute value inequalities. All right, now not knowing what kind of background we all have, okay, we're going to write these answers in interval notation because they're inequalities. All right, so let's make that little note. Answers will be in interval notation. All right, the reason it's going to be in interval notation is because we're not just going to have x equals 4 or x equals 6. These are inequalities. So we're going to have all the numbers less than 6 or all the numbers greater than 2. All right, we're going to have more than one answer. If we're going to have more than one answer, that's when this interval notation comes in handy to be able to write the answer. All right, it also means that whenever we do that interval notation, we can put it on a number line and look at it. All right, and make a comparison there. Okay, so let's take a look. We're going to have two different types of inequalities. We're going to have or inequalities, and we're going to have and inequalities. All right, you are going to be able to identify whether you have an or whether you have an and based on the original, for the most part, original inequality. All right, I should say the original inequality as long as the absolute value bars have already been isolated. Okay, now your or inequalities, if we look at that from a graphical standpoint, okay, I'm just going to do a number line here so that we can kind of get the hang of this. Let's say we got -3 down here. Let's say we've got a 2 down here. We do curvy brackets and square brackets, right? So let's say there's a curvy bracket on the -3, and let's say then, I don't know, let's say we've got curvy bracket then on the 2 as well. Okay, now if it's an or, basically this boils down to the answers are either here, right here, okay, on this side, or they are over here. Okay, ors when we graph them are shaded like this, okay, on a number line. All of my answers are either going to come from the numbers that are over here, or they're going to come from the numbers that are over here. All right, if I were to write this in interval notation, all right, what we have negative infinity down here. We have positive infinity up there, right? So we've all done this. We've done this quite a bit. So this would be a negative infinity up to a -3. We would skip over the numbers there in the middle, and we would go 2 to infinity. All right, so your corresponding, what your number lines are going to look like when you have an or absolute value inequality, and what the interval notation looks like. Okay, now on the and inequalities, all right, without working out an entire problem, we're just going to look from the graph on. Let's suppose I had a -1 here and a 5 over here. Okay, again, we're depending on the way the problem is set up, you're either going to have curly brackets or square brackets. So let's say you had square brackets on this one, just to be different than that over there. All right, but on an and, it's the numbers that are shaded in the middle. All of the answers are going to come right there in the middle. Okay, so if our picture looks like this, our interval notation then is just this section of the number line right here, square bracket, -1 to 5. So this is what your interval notation will look like for an and absolute value inequality. Now, quick, easy way to memorize whether you have an and or an or. Okay, let's put absolute value bars isolated, because I do have to have them isolated for this trick to work. Okay, and on the left hand side, let's add that bars on left hand side. Most of us like it on the left hand side. We like that X on the left hand side. We solve equations that way for the most part. Sometimes in high school, they always teach you move all the left, move all your numbers to the right. Okay, it just kind of works out that way. All right, so I'm going to kind of continue to line this up with ors over here and ands over here. Okay, ors are when you have greater or greater than or equal to. Now, the way I remember that is I say the word greater because these are greater than signs, right? Greater than, or equal to, greater. Okay, if I say greater, and I emphasize the greater, the or part in the word greater, okay, that helps me remember that if it's a greater than or equal to, it's got to be an or problem. On the and, it's going to be less than or less than and equal to. So again, I have to play on my words, less than, it's not and, less than, and you hear the and part of less than, okay, which means it's going to be an and. So I emphasize the words greater for or, less than, and for the ands. All right, it's just a mnemonic. All right, sometimes when you have lots of things to memorize, then mnemonics help. Okay, so basically what we're going to do, we're going to take our absolute value bars and we're going to do the exact same thing. We're going to make sure they're isolated. We're going to solve the equation. We're going to break it up into 2. All right, and then there'll be an extra piece. We already took the opposite of the number. We're also going to have to switch our sign. Okay, so a few things to remember, but not too bad. All right, let's take a look. We'll start out with simple ones and then we'll work our way up. Yes.
So the reason you might need to know what it means is because when we do absolute value equations, we will do what it set up as solution set or
You'll have to know how your solution is going to look. Is your solution going to look like this, where all the answers are on the inside, or are they going to look like they're in 2 different locations? All right, some people can naturally tell when they get down because they can analyze their 2 answers. You're going to have 2 answers just like we did on the equal sign. Some people can just look at that and go, oh, this is greater than this and less than this, so it's got to be this. All right, other people have to actually have more of a memorize a set way to do it. All right, but when we do an example, you're going to see how it's going to fall into an and, or it's going to fall into the or category. Okay. All right, so we're going to start out with really simple first, and then we'll work our way up to more challenging ones. So like, let's say absolute value of an x minus 4 is less than 3. Okay, so this one's going to be a pretty straightforward one. Okay, now if you want to do the memorizing, the absolute value bars are already isolated, which means then I can look right there at the less than, and I know right away it's going to be an and. All right, so if you want to memorize that, that works. However, okay, you're also going to be able to, I'm going to actually probably work this out 2 ways. Okay, so what we've got going here, well, I'm just going to go my 2 ways. All right, so this is isolated. So I'm going to break this up into my 2 inequalities. The first time I write this, I'm going to keep everything the same, except I'm going to drop those bars. So I'm going to go x minus 4 is less than 3. I did not change anything. All I did was drop the bars. All right, now I do know it's an and. I could write the word and in there. You don't have to, it'll just clutter it up. All right, now when I write it the second time, we have one extra step we have to do from before. I write the exact same thing. I drop my bars, okay, so don't get in a hurry here. X minus 4, all right. Now, didn't we take the opposite of the number 3? Okay, we took the opposite before, so I got to write -3. All right, now the extra step, I have to flip the inequality. So the flipping the inequality is the only extra new step from what we just did with the equation. I wrote the first one identically to what I see, I drop the bars. I write it a second time, I take the opposite sign, I flip the inequality. Okay, now we're going to solve inequalities just like we always have. So I add 4 to both sides. The math's not hard. X is less than 7. Okay, over here, I'm going to add 4 to both sides. So X is greater than 1. Okay, now, some people are going to, even though if you don't know this is going to be an and, some people are automatically going to be able to look at this on the number line and know it's an and, because watch what happens when I graph this. I'm going to put these 2 answers on the number line in numeric order. So that means 1's got to be on the left and 7's got to be on the right. Then I'm going to read each one of these inequalities. All right, this says X is less than 7. Numbers that are less than 7 are this way, right? And all the way down here, but definitely over here. This one over here says X is greater than 1. Well, here's 1. The numbers that are bigger are this way. So am I shading on the ends or am I shading on the center? I'm shading in the center. Okay, so this has to be an and. Okay, so you don't have to memorize that. You can look at these 2 things and you can conclude it from thinking about it and on the one number line. Now, these are less than, so these are curvy brackets. Right? I did not write this down on the first one, probably should have. Curvy brackets would be less than or greater than. Our square brackets are going to be with the equal to part, greater than or equal to, less than or equal to, because do I include the number? Do I not include the number? When it's less than or greater than, I am not including the numbers. Okay, not including the numbers. So that's my number line. All right. In interval notation, then the solution is 1, 7. 1,7, curvy brackets on both sides. So that right there is the actual numerical answer. I can view it on a number line. That's my number line. And I know it's an and. So probably in high school, you might have been allowed to leave it like this. Okay, now I want to show you one other thing. All right, so this is kind of the way you did it in high school. This is what it looks like on a number line. Here's your interval notation. All right, you might see something like this in my math lab. Okay, so I'm assuming we all know why we shade. We shade on the number line because we're shading the solutions to this inequality. Okay, that's why we shade. That's telling us where the answers are. And what are we trying to find answers for? We're trying to find answers for X, right? We're trying to find answers for X. So that means my X's are inside here, right? So another way to look at this is all the numbers in between 1 and 7 with X in the middle. So 1 is less than X is less than 7. I used my symbols. All right, now notice these are, when I write it in this form, I will always use less than or less than or equal to, because I'm reading this left to right. Now this, you're going to look at that and go, oh, shoot, that's not right, but it is. Because didn't you remember from middle school when you first learned inequalities, this right here is the exact same thing as saying 1 is less than X, because you can flip it around, right? The 1 is on the pointy side, 1 is on the pointy side. X is on the fat side, X is on the fat side. So this can be written like this. So all I'm doing is taking this and writing it left to right, putting my X in the center where the solutions are. So if you see this notation in my math lab, then that's where it comes from. When you solve this by hand on a test, I will probably have I might have a line for all 4 spots. We might. Okay, or then again, maybe just these 3, but this one, number line, this one, and possibly that one. So those 4 things, I would expect you to then be able to hopefully do when you solve one of these. All right, now that one was kind of straightforward. Okay, let's do one where we've got to do a little bit more. Before I go on, let's make sure we got the prerequisite skills. I just don't know where you are and how much of your prerequisite skills you have. All right, if I had a negative 4x is less than 8. This is just like a inequality thing. You would divide both sides by negative 4, right? Okay, so I divide by negative 4. I divide by negative 4. All right, I would do x. I would have a negative 2 over here. What would I do to that inequality symbol? Flip it. Okay, so we know that. We already, okay, I just want to make sure we already know that. Okay, because that's going to come in handy. All right, we're going to have to know that. Okay, now let's beef it up actually quite a bit here. All right, so let's suppose we've got absolute value bars that are not isolated. Not isolated. So let's do a negative 2 absolute value 3x plus 5. Inside the absolute value bars, close them, add a plus 7, greater than or equal to a negative 13. The absolute value bars are not isolated. Okay, they're not. I've got the plus 7, I've got the negative 2, it's being multiplied there in front, so they're not isolated. So I do not want to look at this and say, oh, that's great or, so this is going to be an or. I don't want to do that yet because they're not isolated. Isolate first, then look at that symbol. All right, so if I isolate first, I'm going to subtract 7. So I'll have a negative 2 absolute value 3x plus 5 greater than or equal to, that'd be like a negative 20. All right, isolate some more, divide both sides by the negative 2 so that the 2's cross out on that left-hand side, divide by negative 2. Now I'm down to just a set of absolute value bars, 3x plus 5. Now, what do I have to do that sign? Flip it because I just divided by a negative, so don't make the mistake I was just about ready to make. So flip it, less than or equal to 10. All right, me flipping it here has nothing to do with the breaking it up into 2 and flipping it there. I flipped here because I divided by that negative 2. That's why I flipped. Okay, it has nothing to do with our other reason why we flipped. Okay, now here I have isolated bars. Okay, once I have isolated bars, then now I can look at this and say this is less than, and this is another and. Okay, less than, this is another and. Okay, good so far? All right, do we need to keep working? How about you finish it and see, since we just did an and like this, I'll pause for just a minute. You keep working, see if you can come up with what this one's gonna look like. All right, not everybody has stopped writing, but most people have stopped writing at this point. All right, so I'm gonna real quickly, so you can just check your lines of work here. On the left-hand side, we're gonna have a 3x plus a 5 is less than or equal to a 10. Over here, we're gonna have a 3x plus a 5 is flip the sign, greater than or equal to, take the opposite, -10. So when you break them up, those are your two equations right there. So you have to have that step right to be able to get the right answer. Subtract 5 from both sides. So this will be x is less than or equal to 5/3. Okay. This one, let's see, 3x greater than or equal to, let's see, -5 would be a -15. X is greater than or equal to a -5. All right, I know it's an and. All right, if I want to do the number line, put it down here. You have to go least to greatest on your number line. The -5's got to be down here. The 5/2 has got to be up here. I've got the equal to part, so that means square brackets. And it is an and, but I can look at it like this as well. X is less than 5/3, that would be shading this way. X is greater than -5, that's shading this way. So yes, it is shading in the center. All right, so there it is on your number line. In interval notation, -5, 5/3. Okay, if I were going to write it as a compound inequality, I didn't actually write that down as a compound inequality a minute ago. I'll do it on this one. I would write -5 less than or equal to x less than or equal to 5/3. Okay, so that was that other version, so to speak. Let's identify this as a compound inequality. I didn't write those words down when I first talked about this. All right, so if in my math lab they would happen to use the phrase write the compound inequality, that's what they're talking about right there. Okay. All right, so far so good. All right, let's see if we can't, because both examples that I've done so far have been ands. Let's see if I can get an or in here so we can get an example of an or. So again, let's do a little bit more challenging ones. It's got some that you have to do some isolating. So let's go to absolute value, 2x minus 3, and then put a plus 10 in there, greater than or equal to 12. All right, so again, we do not want to look at this symbol right now and make a decision because we don't know that it's going to remain that way. Okay, so isolate first. So subtract 10, subtract 10. All right, that'll give me a 2, absolute value 2x minus 3 greater than or equal to 12 minus 10 is going to be a 2 on that side. All right, now on this one, when I divide both sides by 2, I do not have to change the inequality symbol because I'm dividing by a positive number. Okay, so in this one, the sign did not change. All right, but we don't always know that that's going to happen like that. Okay, so now that it is isolated, I can now look right there, greater, or there's the or part coming out. This is going to be an or. All right, if you don't want to memorize that, that's fine, because when you go to your number line, you're going to be able to see it. Okay, I have absolute value. I have an inequality. That means I have to split it up into 2 to get 2 answers. First time I write it, I write the exact same thing I see, I drop the bars. So I'm going to have a 2x minus 3 greater than or equal to 1. I could put the or in there if I wanted, I don't need to. When I write it the second time, I got to remember, drop the bars, flip the symbol, take the opposite sign. So I'm going to write 2x minus 3. Flip the inequality, opposite sign. Okay, that line right there is the important line. All right, if you forget to break it up, you're not going to get this part of the answer. If you forget to break this up and you just work it and ignore those absolute value bars, you only get half your answer. Okay, so that's why this is so important. All right, so I'm going to add 3 to both sides. So 2x greater than or equal to 4, x greater than or equal to 2. All right, over here, add 3 to both sides. So 2x less than or equal to 2, x is less than or equal to 1. All right, now let's suppose that I didn't know from the beginning it was going to be an or. That's okay. When I look at my number line, I have to put the numbers on in order from least to greatest. So my 1 has to go here, my 2 has to go here. All right, take each individual inequality and just see what it says. This one right here says x is greater than 2, greater than or equal to. All right, so these numbers are bigger than 2, greater than or equal to. So square bracket, and it's shading over here. And so over here, x is less than or equal to 1. Okay, well, here's my 1. The equal to part gives me the square. Numbers that are less than 1 are over here. So see, it is an or. It's shaded appropriately. When we have or, my answers are here or they're over here. Okay, so my number line, it's an or. Okay, then we just got to remember that what? Infinity is over here. Infinity is over here. And when I go to interval notation, I'm going to put it right here. For a lack of a better place to put it, I'm just going to literally read off my number line section first. I'm going to have a negative infinity all the way up to 1. Skip over these numbers that are in the middle. Go with my square bracket, 2, all the way up to positive infinity. So that's going to be my interval notation answer. There is no compound inequality for or. Okay, so since I have concluded that this is an or, I definitely can put the or in between there. And this is how you write the or answer always. It doesn't matter whether you're in high school, you're in college, or whatever. There is no compound inequality for or. So right there's the only way to write an or. I can't put them together any other way. This is what the number line looks like. And this is what the answer looks like as interval notation. Okay, so far so good. All right, now there are some special cases. Again, remember how we had special cases with the equations, because the absolute value bar can't be negative. We've got some special cases for inequalities as well. Okay, so special cases. Absolute value inequalities. Okay, so here's our special cases. I'm going to be a little bit more formal on this one. If U is an algebraic expression and C is a negative number, we're going to have 2 scenarios. Okay, so I'm going to use some C's, I'm going to use some U's here. I've got one possible scenario where I could have the absolute value of U, and we talked about this earlier. That's just some algebraic expression. So that could be x plus 4, it could be 2x minus 6. All right, some algebraic expression inside my absolute value bars, and it is less than a negative number, so less than C. All right, this, all right, is a no solution. Okay, just off the bat, no solution. All right, the absolute value, when I take the absolute value of something, it's going to become positive. A positive number will never be less than a negative number. If C is negative, that's never going to happen. Can't. Okay, so an example might be, and it really doesn't even matter what it says on the inside, x plus 4 is less than negative 8. It doesn't matter what I plug in for x. Whatever I plug in for x, I add 4 to it. I take the absolute value. It's going to be a positive number. it can't be less than -8. So that's why this has to be a no solution. So you just look it up. This is your symbol. It's less than absolute value. You got a negative number over there. It's no solution. Okay, now second scenario would be absolute value of some algebraic expression greater than C. Well, absolute value of something greater than a negative number. Well, isn't all positive numbers greater than all negative numbers? So this one is all reals, all real numbers. Because it doesn't matter what I plug in, I'm going to get a positive number. Positive numbers are always bigger than negative numbers. So that one's all reals. Okay, so an example would be, how complicated? Let's make this, well, let's do this exact same thing. X plus 4, but let's say it's greater than -8. It doesn't matter what I plug in, whatever, even if I plugged in a -10, a -10 plus 4 is -6, take the absolute value, that gives me a positive. Positive 6 is always greater than -8. This is always good. So this is all real numbers. So two special cases that you do actually have to memorize there. There's the examples underneath the rule on top there. All right. Now, there was